Breadth first search is a search algorithm which is used to search or traverse the graph. It is a very common algorithm. It is also part of AI search strategy and it falls under the uninformed or blind search. Breadth first search has a wide range of application. It is used in peer-to-peer networks such as BitTorrent client, then web crawlers, in GPS navigation, and in many AI problems. Many AI problems can be solved using BFS. So for any breadth first search problem, three things are to be needed. The first one is the graph, which represents the search state space, then the strategy or the algorithm, and the data structure or this fringe, which is also known as fringe. So in case of breadth first search, the data structure used is queue. It works on first in first out manner. Along with this, we will also be having a list of booleans named visited, where the indices of this list represents each node and its value is a type of boolean which states that if that node has been visited or not. This is used to avoid the cyclic traversal in the algorithm. So if we don't use this list, the algorithm will get trapped into these cycles. The traversing will go on continued in such cycles. So let's start. For in case of BFS, we have to define a root or a start node. So we'll have a 0 as a start node over here. Step, the 0 will get added into the queue. It will get dequeued and the adjacent node of 0 will be explored. So now first thing, 0 got dequeued, it will be marked as visited and it will get added into the answer string. Its adjacent nodes will get explored, that is 1, 2 and 3. It will get added into the queue and marked as visited. Now the queue will get dequeued, that is the first element will pop out, it will get added into the answered and its adjacent nodes will be explored. So in case of 1, you can see that 0 and 2 are the adjacent nodes and they are already visited, so that's why they won't get added into the queue. Moving further, the 2 will the adjacent node of 2 will be explored. So 0 and 1 are already explored, but the 4 is an adjacent node and it hasn't been exploded, so it will get added into the queue and marked as true, marked as visited. The this 2 will is also got added into the answer string, and in this way the traversal will go on. So finally you can see that all the nodes got visited and we got the answer, the traversal of this graph, that is 0, 1, 2, 3, 4, 5, 6, 7. So let's implement breadth first search in Python. We'll be doing three things, that is we'll define a data structure to store the graph, we'll create a function to add edges between the nodes of the graph, and we'll define BFS function. What we have done over here, we have imported default dict, that is will be representing the graph in the form of dictionary, and we have created a function add edge. So on passing the parameter, the edge will be added between u and v. So let's store this graph given over here in our program. So now our graph is ready. We'll be implementing the BFS function. So I will write the basic steps or basic algorithm of the function first, and then I'll write the code. So this is the basic algorithm for breadth-first search. First we'll be defining a queue data structure, an empty queue. Then we'll define a list named visited. It is a Boolean list. Then we'll enqueue the start node into the queue. Then a loop will start, which will run until the queue is not empty. In the loop, we'll first dequeue the node from the queue. We'll mark that node as visited, and we'll explore its adjacent nodes. So if the adjacent node is not visited, that unvisited node will get added into the queue and it will get marked as visited. So that's it. This simple algorithm will perform the breadth-first traversal. So let's start the code. Over here we have defined a list named as queue. Then we have defined a list of boolean named visited, which is of length equal to number of nodes in the graph and initialized to false, as all the nodes are unvisited in the beginning. We will also define a variable answer to store the answer of traversal. Now enqueuing the start node. So until the queue is not empty, that is while queue, dequeue node from the queue. So for dequeuing the node from the queue, that is queue dot pop, as it is a queue, so we'll use pop 0, and we'll store this dequeued node in the variable token. Now mark the dequeued node as visited. Then explore its adjacent node, that is for over here what we have done, we have represented the graph in the variable named graph, which is a dictionary. Now we have dequeued a node and stored it in the token. Now the token will act as a key and its values are the adjacent nodes. For each iteration, this adjacent node will be assigned to those values. So if adjacent node is not visited, then enqueue that adjacent node into the queue. So that's it. This is the simplest program for breadth first search. So we have defined a queue, then visited, then a string for answer, then we have appended the first start node into the queue, then we started the loop, we dequeued the first element. After dequeuing, we will write ans equals to ans plus string token to store the traversal. So this function will be returning the answer. We'll call the BFS function over here, starting the traversal from 0th node. We'll print the answer. So let's check this program. That's it. So we got the traversal 0, 1, 2, 3, 4, 5, 6, 7. We will check for some other start node like for 7.